Welcome back, my dear students. We are moving on to our next problem. Exercise 1.2, question number 6. Question number 5 is, in our previous video we have discussed a question regarding 4 raised to n, and we have to check whether it will ever have an n number with an n digit 0. So question number 5 in your exercise is similar to that. Instead of 4 raised to n, they have given the question as 6 raised to n. So the solution is similar. Instead of finding the factors of 4, you have to find the factors of 6. 6 is 2 into 3. So there is no factor of 5 there. So that term will never end with digit 0. That is the solution. So I am not going to discuss that again because we have done similar problem before in our previous video. You can just check that video. Now I am moving on to the next problem, that is question number 6. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So we know what are composite numbers and prime numbers. We have studied about that. Composite numbers. What are composite numbers? Tell me. Composite numbers are numbers that have factors other than 1 and that number itself. Whereas prime numbers are numbers greater than 1 and have factors 1 and that number itself. For example, 2, 3 and all are prime numbers. They have factors 1 and that number only. So they are called prime numbers, and composite numbers are those numbers they have factors other than 1 and that number. So we need to prove these two numbers are composite numbers. We need to prove whether these two numbers are composite numbers or not. You may think that why we are writing in this, why the question is like this. They can just multiply and give the result, right? So what we have to do, first we have to multiply the terms and write it as a number. Okay, we have to simplify this. They are giving us a little bit tough task, that's why they have given it in this manner. We have to multiply the terms first and then we have to factorize it. Then only we can find out whether they are composite numbers or not. So before moving on to the problem, let's have a look on BODMAS rule. BODMAS. You might have heard about this. BODMAS is bracket of division, multiplication, addition, subtraction. That means when we are given some problem with multiple like in a single problem, if they are given, if we have to do addition, subtraction, division, multiplication, all sorts of things in a single problem, first what we have to do, if there is some bracket, if something is written in bracket, then first we have to simplify the terms inside the bracket, that is bracket of. Of means bracket into bracket like this. So of means into bracket of division. After bracket of, then what we have to do? We have to do division. After division we have to do multiplication, then addition, and last only subtraction. This is the BODMAS rule. Then now you look into a question. Here we have multiplication and addition. So as per BODMAS rule, what we have to do first? Multiplication comes before addition. So we have to multiply first, and that result we have to add with this. Okay. Some people may do first addition, or sometimes they will do 13 plus 13 and that result you will multiply with 11 and then 7. It is wrong. First we have to multiply the whole term and add that result with 13. Okay, that is BODMAS rule. Okay, let's multiply the terms and see what are the results. 7 into 11 into 13 plus 13. 7 into 11, 77. 77 into 13. 77 into 13. 7 3s are 21. So 21, 22, 23. 7. 7. 1. 1001 plus 13. 1014. So this number is 1014. Our first number is 104. We have just multiplied the terms and we have done the addition also. So we will get 1014 as the first term. What will be the second term? 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. 7 6 are 42. 42 into 5. Okay, 42 into 5 4 are 20. 20 into 3. 60. 60 into 2 120. So we will do 42 into 120. So 2 this are 4. 4 this are 8. 2 4 4 5040. This will come 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is 50. What we got? 5040 plus 5. 5040 plus 5 is 5045. So we have simplified the question now. Our two terms are 1014 and 5045. Okay. We have to check whether these two numbers are composite numbers. Okay. Once I am going to factorize 1014. Why I am factorizing the numbers? Because we know that for prime numbers, they have only two factors, that number and 1. Whereas in composite number, we have factors other than 1 and that number itself. So when I am factorizing it, if I am getting some other factors other than 1 and 1014, that number will be a composite number. Okay. This number I can factorize with 2, right? Because the last digit is 4, which is an even number. So I can factorize it with 2. 507. 507. From this stage itself, I can say that this 1014 is a composite number because what? Because it has a factor other than 1 and that number 1014. 2 is a factor. So any number which is having a factor other than 1 and that number, it will be definitely a composite number. Okay, this stage itself I can say that it has got other factor as well. So 1014 is a composite number. Here, what about this 5045? By looking at the number itself, we can say that this number is a composite number because the last digit is 5. That means this number will be definitely divisible by 5. So 5 will be a factor of this number. So this number also is a composite number. We can factorize it with 5. So this number also will be a composite number. I'll just do it. So 507. So we can divide it with 3. So 1 2 will come 6 9 169. 169 is in 13, right? 169 is in 13. Yes, 169 is in 13 into 13 is 169. So we have completely factorized 1014. It has got other factors other than 1 and 1014. What are the factors? 2, 3 and 13 are the factors of 1014. So what we have to write? Since 1014 has factors other than 1 and 1014. 1014 is a composite number. 1014 is a composite number. Next question is 5045. I am going to factorize it with 5. 1009. So here we can write, since 5045 has factors other than 1 and 5045, it is a composite number.